Google probably recognized that, they watched Nvidia and saw that you can make more money selling the pickaxes than painting for gold. And so, it made sense to enable Meta to do this.
Yeah, when Nvidia's market cap exceeded that of Alphabet, that I think probably turned some heads.
Yes. Welcome to the Byrne-Wheeler Report. In this episode, we're going to talk about Marvell's acquisition of Celestial.AI, the disclosure that Trainium 4 will use NVLink Fusion, ARM's announcement that NVLink Fusion is available with its Neoverse CPUs, and enthusiasm and discussion around TPUs. So to begin with, Bob, Marvell's announced that it's acquiring Celestial.AI, and in a nutshell, what does Celestial do?
So in a nutshell, I would look at them as being a next generation co-packaged optics vendor targeting very high bandwidth interconnects such as scale-up interconnects for AI. They've also talked about memory disaggregation over optics, but that's kind of a longer term target.
And we talk about next generation. What are a couple of the things that distinguish next generation co-packaged optics from how things are done currently?
Yeah, so there's really two things. First, compared with Broadcom and Nvidia, for example, where they're doing co-packaged optics that are compliant with existing standards, those designs are using the same DSP-based SerDes that are integrated into an XPU or an ASIC that would drive passive copper cables or an optical transceiver. So you've got a fairly powerful DSP in your ASIC or your switch. And the Celestial design is simpler in that it's basically kind of a slow and wide approach, which is running the lane rates lower and using NRZ modulation instead of PAM4 modulation, but avoiding the need for DSP and a lot of digital processing. And so their claim is that their power efficiency is about 2x better than that of Broadcom's latest design, for example. And so that's the first big difference. And then kind of from more of the vision of the product is the idea of a photonic interposer that can actually go below your ASIC and move the optical interconnect into the middle of your ASIC die and not be constrained by beachfront density on your ASIC. And so both freeing up the beachfront for HBM and other types of I/O, and also potentially getting a lot more bandwidth out of that ASIC by going somewhere out of the middle of the die with this photonic interposer.
Okay. And is it fair to say this is really possible because it's going into a hyperscaler that controls both ends of the wires? They are, a merchant switch company really needs to conform to standards. When you're deploying data centers with equipment that you have influence over the design of and the chips inside, you can go with something novel and not yet standardized to achieve these power efficiency improvements, as well as this roadmap to a totally different way of doing chip-to-chip interconnect.
Yeah, I think that's fair. We generally look at this as a kind of a bookended link where you have the same thing on both ends, or you have a switch on one end and XPU on the other end, but it can be proprietary. That's what we see implemented today, and all the XPUs, they all have proprietary scale-up interconnects, and we haven't really gotten to standards yet, but we'll talk a little bit more about that. But so one of the things that came out of the acquisition announcement was that Marvell has given a warrant to Amazon related to this acquisition. So it appears that Amazon was one of the lead customers for Celestial. Celestial had mentioned 2 hyperscaler customers, but clearly Amazon is one of those. Amazon has their proprietary NeuronLink scale-up interconnect, and so presumably the goal for them would be to scale their NeuronLink over optics.
Okay, then as far as other companies that are pursuing similar novel optical interconnects, there's Lightmatter, and who else is out there?
Yeah, so Lightmatter is the most similar in that they also are proposing this kind of photonic interposer where you could put an ASIC on top of your photonics and, again, kind of get away from the beachfront issue. And so conceptually, they're they're quite similar. The technology is different. They're using different types of modulators. Celestial claims that their modulators are more tolerant to the kind of a very challenging thermal environment of a very high-powered ASIC. So when you're talking about a 1,000-watt XPU or something, it's not actually the absolute temperature as much as the delta, I guess the kind of the slew rate and how quickly the temperature
Basically, the frequency might drift if the temperature rises or falls.
Right. So micro ring modulators, which Nvidia uses and Light Matter uses and IR Labs uses, are all have to have heaters to kind of basically adjust for that thermal drift. And there's a certain time constant associated with that. And so it's a question of kind of can they keep up with when you're talking about these very high powered chips. So Marvell did have their own existing CPO technology in-house, but it was more similar to the Broadcom and Nvidia approach, where they were essentially working with standard optical interfaces and just integrating optical engines with more channels. So they weren't getting a huge difference in power efficiency or density compared to kind of conventional optical interfaces. So this is more of a, I would say, a next generation approach to CPO where you can get theoretically much higher optical densities.
The next item on our agenda was at AWS Invent, Amazon disclosed that Trainium 4 would use NVLink as a chip-to-chip interconnect, or more specifically NVLink Fusion, the licensable version. And I was wondering if you had any thoughts as to why would they use NVLink when they could use UA-Link exclusively. And then I think the other thing to discuss is when we brought this up before, NVIDIA had indicated that they would link NVLink Fusion out to not just CPU companies, but also companies making NPUs. And I think we thought that was a little strange at the time because they're giving a technology or someone with a computing solution. Just kind of curious. I was just thinking, I was just wondering what you thought about why AWS would use NVLink at all.
Yeah, it was a surprising development. And I think from Amazon's perspective, the beauty of using NVLink for scale up on Trainium 4 would be the ability to take a one rack design and mix and match NVIDIA GPUs and Trainiums and basically have a more flexible design rather than having kind of bespoke Trainium infrastructure and bespoke GPU infrastructure, which is what most of the hyperscalers have today. But
I think the key point there is, they're deploying at a really rapid rate, and the way you do that is you have more of a cookie cutter approach, and they had to use something, right? So it'd either be proprietary UA-Link or NVLink, and there's really no getting away from NVIDIA GPUs. So,
right. They have to have NVIDIA GPU instances for their cloud customers, right? So they're going to be deploying those racks in any case, and so the ability to use the same rack for Trainium makes sense. I think from NVIDIA's perspective, it allows them to continue to control the overall system architecture. So it's a plus from that perspective for NVIDIA. And obviously there's pressure from standards like UA-Link and even scale-up Ethernet, or ESUN now as it's called in OCP. And reportedly, Amazon's actually going to build two different versions of Trainium 4, one with NVLink and one with UA-Link. Now, as we discussed before, the NVLink Fusion for the backplane type of NVLink is going to be supplied through a chiplet, an NVIDIA chiplet, and so you can imagine that the approach would be to have a common Trainium ASIC attached to two different types of chiplets, depending on what kind of scale-up interconnect you want.
And could they use in terms of the actual, the wiring, could they use the same wiring, the exact same racks, but run a different physical layer over them?
That would be a challenge. But interestingly, the other announcement was that Astera Labs is going to participate in the NVLink Fusion ecosystem, and Astera Labs is supplying PCI Express switches to Amazon for their Neuron Link scale-up interconnect. So it begs the question of how far that goes in terms of, will Astera Labs actually be building NVLink compatible switches, or maybe they'll just be doing retimers or something? We don't really have all the details yet, but fundamentally what we're seeing is a kind of an ecosystem forming here around NVLink, and to me it definitely undercuts UA-Link. And then, as we had talked about before, AMD is actually using scale-up Ethernet in their first rack scale architecture, Helios. So we're going from proprietary to standards and sort of the pseudo-open interconnects like NVLink, and it's going to take a while for it all to settle out.
Right. Yeah, I wonder if some of it's just NVIDIA looking to keep kind of, like you said, kind of control the ecosystem, control of the overall architecture. And that's a zero-sum game. The more they have, the less scale-up Ethernet or UA-Link has. And if one of them doesn't reach critical mass, then, it's one less thing for NVIDIA to worry about.
Their networking business has gotten quite large. Their new definition includes the NVLink switches, but the numbers are big. And in fact, if you look at just the Ethernet numbers, they've surpassed Arista in Ethernet. So they've gone from sort of zero to market leadership in AI networking, Ethernet for AI very quickly.
Yeah, I think in retrospect, the Mellanox acquisition is going to go down as one of the best semiconductor deals in all time. In a way, it was even worse than zero. It was small. Like when it's zero, you're like, hey, you can have this optimism. You're going to build something and it's going to grow out. But it had been around for a while, and was rather small, and now it's just this huge business and very supportive of the NVIDIA's technology strategy around the GPUs and the whole data center architecture.
Yeah, I think they had the vision of building their kind of full stack approach, and that was a very important piece.
Yeah. The other NVLink Fusion related news was a few weeks ago, ARM announced that their Neoverse CPUs, these are their CPUs targeting infrastructure applications, were going to be, they didn't use the term pre-integrated, but really essentially pre-integrated with the CPU and available from ARM. When you license from ARM, you have a few different options. You can take just the CPU, you can take a subsystem, you can take it as soft IP or what they call CSS, which is more like old-fashioned hard IP. And, the thing I saw about this that I liked was that let's say you're a hyperscaler and you're going to use Neoverse to build a CPU, you can just go to one place and get the Fusion interface integrated, and you can get it. I think the license would come through ARM. It'd be a pretty clean way of getting a NVLink enabled CPU. I don't know. What were some of your thoughts or ideas around this?
Yeah, and I think NVIDIA is less protective of the chip-to-chip variant of NVLink. It's not necessarily where they have the most value add, like the backplane, which they're driving, at rates that nobody else is right now. They're kind of a generation ahead, and interoperability is a lot more challenging when you're talking about driving a backplane than driving chip to chip. So it makes sense to enable their both direct customers and others to basically support NVLink on CPUs for AI.
Yeah, I think as for ARM, they're very much aligned with the hyperscalers and others that are developing their own server processors. The emergence of hyperscalers rolling their own has been very good for ARM. And, I think they're keen to meet the needs of that customer base.
Yeah, absolutely. There are a number of very high volume designs now between Google and Nvidia and others, and so it's had a significant impact.
Right. Okay. The last thing on our agenda, I wrote it down as TPU mania. It's been reported, although I don't think it's confirmed that Meta was going to run their own TPU clusters. So not only is there a big cloud company that's other than Google that's going to use the TPU, but they would actually have systems on premise. So that seems like a pretty big deal. Did you have any particular thoughts about this?
Yeah, I mean, unfortunately, nothing's been confirmed at this stage, but the big shift is really the idea that Google would move to essentially being a merchant supplier of TPUs, and that would put them in more direct competition with Nvidia rather than just selling their TPU-based cloud services, which is traditionally how they've served those.
Right. And they're supplying these to a competitor. I mean, Meta and Google are the two big digital ad companies, for example, and they compete in other regards. But to your point, Google probably recognized that, they watched Nvidia and saw that you can make more money selling the pickaxes than painting for gold. And so, it made sense to enable Meta to do this.
Yeah, when Nvidia's market cap exceeded that of Alphabet, that I think probably turned some heads.
Yes. And then from Meta's perspective, they have options. They've been using NVIDIA. They could certainly use AMD GPUs, and they've developed their MTIA, which is their own proprietary chip. I mean, this tells me that MTIA is, I mean, I infer from this that MTIA is not competitive and not suitable for their needs.
Yeah, there were reports that they had a training version of MTIA, the MTIT, coming out next year. But even those reports, it looked like the volumes were going to be quite small. So it didn't look like it was going to have much of an impact in any case. So not sure what the future holds for MTIA. Certainly Meta's, well, not just Meta, but all of the model developers are exploring various options for how to get compute. So there was also a report that another frontier model developer was going to acquire $10 billion. They have a $10 billion deal with Broadcom.
Yes.
But the odd thing is that it's apparently to supply rack scale systems. And so one theory I've seen reported there is that they'll actually be supplying Google TPU-based platforms to this model developer, which might be Anthropic, might be somebody else.
Yeah, because I think Anthropic is running some workloads on TPU already.
Right.
And, I think it was last year, Apple was doing some Siri development with the TPU. And the thing is, the TPU, we talk about it as a chip, and there's certainly pictures of it as a chip, but, right now it's this pod, this thing that is about the size of a shipping container where topologically speaking, logically, it's a 4x4x4 cube with interconnected neighbors and this optical switch connecting the far nodes, and I wonder if there is this Broadcom idea would suggest that maybe there's something more modular that. I mean, I think the cube actually physically would be a rack. Like the customer maybe is ordering up a specific scale and not just a massive pod the size of what Google deploys.
Yeah, it's hard to. I don't want to read too much between the lines, but I think Hawk Tan literally said that the $10 billion would begin and end in one quarter. So it did sound like one giant cluster valued at 10 billion. Now, I don't know if that is literally the case, but that is what he actually said. But in any case, it's true that we're not just talking about TPUs. We're talking about, first of all, racks, which include the TPUs and CPUs, which are Intel in Google's case. And then you have the optical circuit switch, which is a Google system.
Right.
And I don't know that Google wants to be in the business of selling optical circuit switches. So one of the things we are seeing is that there are some of the optical vendors are entering the market with merchant optical circuit switch offerings, but not clear if those could easily be integrated into a Google, kind of rack scale architecture.
Right. I guess the alternative is to go Cray style and make lay out your racks in a physical ring, and so you don't have to have an optical to lash the far points together to complete the torus.
Yep, that would be an option up to a certain scale.
Okay, well, with that, we've covered the major news. And Bob, I hope you feel better. And as I think I will see you next week relative to this recording date.
Yep, we will both be in Silicon Valley next week, so look forward to that.
Okay, well, everyone, thanks for tuning in. And until next time, be well.
It's all about the paintings, baby.